Monsoon is magical. Monsoon is enigmatic. Monsoon is romantic.
प्यार हुआ इकरार हुआ है प्यार से फिर क्यों डरता है
Monsoon is joyous. Monsoon evokes varied emotions. But the fact remains, monsoon is lifeline of India, renewing its natural resources every year. At least for the last 2 million years, monsoon is keeping its date with India in the month of May, when it taps the door at Kerala. Soon, travelling with winds, it covers entire country with clouds and rains, and withdraws in late September. Hence, the period from June to September is called monsoon or rainy season, which is technically southwest monsoon. India gets more than 80% of its rains during this period. Any variability in onset, withdrawal or quantum of rainfall during monsoon greatly impacts agricultural yields, water resources, power generation, economy and the entire ecosystem. It is considered imperative to know variations in monsoon rainfall well in advance. Knowledge beforehand would help reduce or mitigate the diverse impacts related to excess or deficient rainfall. It will allow policymakers, farmers, power generators and other stakeholders to develop suitable mitigation plans and consequent actions. In earlier days, traditional wisdom of elders guided the monsoon predictions by observing sudden changes in behavior and appearance of various insects, birds and animals. But with the emergence of scientific era, these predictions went into oblivion. The first science-based forecast of monsoon was initiated in 1882 by Sir H.F. Blandford, the first chief reporter of India Meteorological Department, IMD. But regular series of forecasts began on 4th June 1886, indicating quantum of rainfall during entire monsoon period. When world-renowned meteorologist Gilbert T. Walker joined IMD as Director General, he introduced correlation and regression techniques for long-range forecasts. In 1988, IMD introduced the 16-parameter power regression and parametric models. But it miserably failed to predict the drought conditions in 2002 and 2004. Even after the introduction of new statistical forecasting system in 2007, IMD could not predict drastic deficiency in rainfall in 2009. The chief reason being very low prediction skills based on statistical models.
Statistical models are generally good when the rainfall is likely to be normal. Whenever there is a deviation from the normal rainfall, whether on the positive side or on the negative side, in general it has been found that statistical model does not perform well. And therefore, whenever monsoon has been very bad or deficient monsoon rainfall or excess monsoon rainfall, the statistical model which IMD was following were not giving very accurate results.
On the other hand, international climate centers were using coupled models having very high prediction skills of seasonal rainfall over tropical oceans. Indian meteorology was lagging behind mainly due to lack of trained manpower to work on development of latest models, high-performance computing infrastructure to run these models, and coordination and synchronization of knowledge gained at academic and R&D institutions to improve operational models. The Earth System Science Organization ESSO of Ministry of Earth Sciences, Government of India launched a mega project, the Monsoon Mission, in 2012.
India Science is an internet-based science TV channel initiated by the Department of Science and Technology, Government of India, implemented and managed by Vigyan Prasar. India Science on the URL www.indiascience.in is a bilingual channel with content in Hindi and English. It can be accessed on any internet-enabled device. This video platform is dedicated to science and technology knowledge dissemination with a strong commitment to spreading scientific awareness, especially with Indian perspectives, ethos and cultural context. The India Science mobile app can be downloaded from the Google Play Store and Apple Store.
The Earth System Science Organization ESSO of Ministry of Earth Sciences, Government of India launched a mega project, the Monsoon Mission, in 2012.
Monsoon Mission was a transformational initiative of Government of India, particularly Ministry of Earth Sciences, to accelerate the effort to improve the monsoon rainfall prediction capabilities for different time ranges, right from 24 hours ahead to a fortnightly ahead and 1 month ahead and a season ahead, so that we can have a good handle of planning our activities, whether it is agriculture or water resources, etc., which are critical for our economic development.
With a detailed roadmap, time-bound targets and well-conceived strategies, the multi-institutional and collaborative project was initially sanctioned for 5 years with an outlay of Rs 400 crores. It was a watershed moment for Indian meteorology. Improving monsoon prediction over the entire country on all time and space scales is the overall objective of the mission. Technically, Monsoon Mission aims to set up a state-of-the-art dynamical modeling framework with reasonably good and reliable prediction skill. It also aims to build a high-end infrastructure to support modeling activities and develop a working partnership between the academic and R&D organizations, both at national and international levels. Mission comprises 2 distinct submissions with specific targets. First, forecast on extended range to seasonal time scale, that is 16 days to 1 season. And second, short to medium range forecasts of up to 15 days for rainfall, temperature, winds and extreme weather events. 4 premier institutes of Ministry of Earth Sciences: ESSO, Indian Institute of Tropical Meteorology at Pune; ESSO, National Center for Medium Range Weather Forecasting at Noida, Uttar Pradesh; ESSO, Indian National Center for Ocean Information Services at Hyderabad; and ESSO, India Meteorological Department at New Delhi, partnered and collaborated vigorously to make Monsoon Mission a grand success. Besides, Monsoon Mission also sponsored specific projects to national and international R&D organizations to develop linkages and working tie-ups. The specific responsibility to develop a model of monsoon forecast for extended range to seasonal time scale was assigned to ESSO IITM.
IITM plays a very major important role. It's almost like the anchor for Monsoon Mission. If you look at it, we run the program from here in IITM on behalf of the Ministry of Earth Sciences, and we also, or whatever the research that is being done in Monsoon Mission kind of either is done at IITM or it kind of passes through IITM. And whenever any external research is done by, let's say, a foreign university or an Indian university or an Indian research entity, it kind of comes to IITM. We check out what the quality of the research that has been done and whether that idea, the formulation or the changes to the model, are they worthwhile to put it into the new forecasting system. That is kind of tested out by IITM, rigorously tested, and then it kind of goes into the production model.
The institute selected Ocean Atmosphere Coupled Dynamical Model Climate Forecast System version 2.0 as the base model for further refinement to suit Indian conditions. The model was adopted from the National Centers for Environmental Prediction, USA. Dedicated team of weather scientists at IITM worked tirelessly on the state-of-the-art facilities created under Monsoon Mission.
We have to get whatever research that happens in Monsoon Mission should be translated into operational forecasts. So, the whole idea of the Monsoon Mission is to have a significant societal impact. So, to do that we have to, all scientists have to work on single modeling system. So, that was the biggest challenge. So, we have to bring all scientists to work on our modeling system.
Doppler radars are playing key role in early detection and warning of heavy rainfalls, cyclones, hurricanes, etc. A dedicated network of Doppler weather radars has been set up at strategic sites to track direction, height, intensity and movement of weather systems, and the data thus gained is analyzed to have precise information on rainfall, monsoon depression and other extreme weather events.
So, here I am showing you the signature of a depression which was monitored by Doppler weather radar. These echoes have been received by the Doppler weather radar. We can see here that how the system is well organized here, and whenever the system moves here it goes in the anti-clockwise direction. And as we can see from this color table also, when we go from the blue towards the red color, that shows the intensity of the precipitation, amount of the rainfall.
Tracking is done round the clock and data is uploaded on the site of IMD regularly at 10-minute intervals. The range for detection of weather systems is 500 km, but for velocity measurements, the effective range is nearly 250 km. Monsoon Mission is making effective use of weather satellites in weather forecast by developing RGB images of upper atmosphere on 6 spectral bands. New images are uploaded at every 15-minute interval.
During the monsoon season, depression and low pressure area is formed in the Bay of Bengal or the Arabian Sea, and these low pressure area or depression is being monitored with the help of satellite images. As they progress from the Bay of Bengal ocean to the land region, they are continuously being monitored by the satellite images, and the forecaster can predict how much area has been covered by the rainfall and how much rainfall has been occurred in the different regions, as well as the progress of the monsoon taking place.
With the help of RGB images, different types of clouds are identified with their height and temperature that helps in forecast of rainfall along with its intensity on specific areas.
India Science is an internet-based science TV channel initiated by the Department of Science and Technology, Government of India, implemented and managed by Vigyan Prasar. India Science on the URL www.indiascience.in is a bilingual channel with content in Hindi and English. It can be accessed on any internet-enabled device. This video platform is dedicated to science and technology knowledge dissemination with a strong commitment to spreading scientific awareness, especially with Indian perspectives, ethos and cultural context. The India Science mobile app can be downloaded from the Google Play Store and Apple Store.
High-performance computing facility has been created with combined performance of 5 teraflops, and the supercomputer installed at IITM ranks 24th in the world in its computational ability. The state-of-the-art IT cell created under Monsoon Mission is at the heart of weather forecast, working 24/7.
IT department is backbone of the forecasting system of India Meteorological Department. It deals with the collection of observational data from various observatories throughout the country as well as at a global level. The information collected is passed on to the forecasters almost in near real time for analysis at their end, generating the product, forecast products, and in turn these forecast products are again disseminated to various stakeholders via various communication channels which are dealt by this IT division.
To improve the skills of short and medium range weather forecasts, that is up to 10 days in advance, ESSO, National Centre for Medium Range Weather Forecasting, worked on a unified model of UK Met Office.
NCMRW is the lead modelling centre of MOES, and we are associated with Monsoon Mission in a big way. One is that we are the lead data assimilation centre for the MOES and the whole country. So we provide the initial conditions required for running the Monsoon Mission models, and we also operate a seamless prediction system based on the unified model, which is an additional one to the one we have with the US based system. So we also, that modeling system can work from small scale to large scale, from time scales from short range to medium to long range to extension and seasonal also.
Under the Monsoon Mission, this centre could develop infrastructure for atmospheric data assimilation for both the USA and UK models.
In our weather and climate system, there are many scale of things happening. So people used to develop and run models at different scales. But now we have developed a model which can be used across scale, from shorter scale to climate. So in this center now we have the medium range forecast, and we have tested the model in the shorter climate scale, that's monthly to seasonal, and the same model can be used in the climate scale, decade to century. That's one of the uniqueness of this seamless modeling framework. And it has components like sea ice, land surface, ocean and the atmosphere, and the atmospheric model goes up to stratosphere. So we have seen the stratosphere has an impact in the monsoon. So earlier models were not resolving the stratosphere, so this model resolved the stratosphere also.
ESSO, Indian National Centre for Ocean Information Services, played a critical role in grand success of Monsoon Mission by providing initial conditions of ocean data for different forecasts. The ocean data assimilation system is set up at this centre for the purpose.
Basically, we contribute in three major parts. First and foremost is we manage several observing systems out at sea, which are providing data on the upper ocean as well as the lower atmosphere. So this data we process, quality check and provide it to the weather forecasting purposes, including the purpose of a monsoon mission. Second is that we need to understand how exactly the energy exchange between ocean and atmosphere takes place. So during 2012-2015, we conducted several cruises in the Bay of Bengal to understand how the ocean is mixing and how the ocean is balancing the heat from the atmosphere and how the heat is exchanged to the atmosphere, because that is going to determine the most crucial factor which goes in the monsoon prediction models like sea surface temperature. The third contribution from inquiries is the institute called IITM. They are the ones who are developing that coupled model for the prediction of the monsoon. But that model needs initial conditions. Initial conditions has to come from the ocean, and we provide those initial conditions to IITM.
The excellent coordination, synergy and commitment between the team Monsoon Mission has gained what it aspired earlier. Now, we have a dynamic seasonal model with highest skill among global models in the world.
We have now the world's highest resolution model. It is the resolution means the distance between grid points is finer than what the Americans or the Europeans use. So, we have now running it at 12 kilometers, while the Europeans use it I think around 19 kilometers. So, we are doing the world's most finest global resolution ensemble forecast model. It is a matter of pride, and this was possible only because we had this monsoon mission, and these models were developed within the monsoon mission.
On the scale, our prediction skill has improved from 0.49 to 0.7, which is a sort of record in such a short span of time. Scientists are now able to predict active or break cycles of monsoon at extended range, which is at par with the best in the world.
This prediction was done on 19th July when it was already active, and we can see that there are some situations when monsoon was very active for almost 20 days. There was another situation when monsoon was very weak, then again slightly active, and then again it was weaker for longer period.
Monsoon prediction systems developed under Monsoon Mission were transferred to IMD for operational use in 2017. And that was the target of Monsoon Mission Phase 1. Thus, a new era of monsoon forecast began with accuracy at highest level.
For effective management of monsoon, the prediction is needed in realistic term with higher accuracy for all time scales. Say a very short range forecast like a few hours, which is popularly called as nowcast, then short range forecast say up to 3 days, then medium range forecast from 3 to 7 days, then extended range forecast, that is forecast up to next 2 weeks to 1 month, and then of course seasonal forecast for a particular season. So, Ministry of Earth Sciences has brought up the various models under the Monsoon Mission project to address the requirements of more realistic, more accurate, more reasonable and usable forecast, utilizing the models for all these 4 time scales, starting from nowcasting to short range, medium range, extended range and seasonal forecasting.
Monsoon Mission also made sure that the forecasts reach to stakeholders well in advance so that adequate measures may be taken in time. In agriculture sector, the Indian Council of Agricultural Research is making good use of monsoon forecasts by issuing advisories on seasonal to daily basis to farmers to plan their activities accordingly.
Sowing of the crops, anyhow, that will be based on the prediction forecasting. We are advising them to sow the crops, what crops to be grown. If monsoon is delayed, what crops or what measures have to be taken, what type of crops or what crop varieties to be taken, and all those they are helpful. And during the crop also, any agriculture operations, suppose you want to apply the fertilizer, if forecast is there, heavy rainfall will be there. Then based on the forecast, we develop advisories and we will advise the farmers not to go for fertilizer. At the time of harvest also, if heavy rainfall forecast is there, then we will advise the farmers not to go for the harvest.
To continue the endeavour with new targets, Ministry of Earth Sciences launched the Monsoon Mission Phase 2 program for next 3 years, 2017 to 2020. The new phase emphasizes on predicting extremes and development of applications based on monsoon forecasts.
You know that climate has been changing and the global warming is a now well known aspect to everybody, and associated with that there are also, it has been shown, observation all over the world that extreme weather and climate events are increasing, like your heat waves, cold waves, droughts, floods, number of tropical storms. In some places tropical storms are increasing, its intensity is increasing, number is increasing. At the same time in some other places it is decreasing. So, this Monsoon Mission has given actually a handle to cope with the situation.
Soon, scientists would be able to issue specific forecasts for specific sectors.
With this advancement in the modeling framework, we have introduced the new services like heat wave warning. For last 3 years, we are providing the long range forecast of temperature and heat wave conditions in the country in the month of March for the ensuing month of April to June. Similarly, during winter season, India experiences cold wave and people also are affected because of the cold wave, especially in the northwest India. So, with this modeling framework under the Monsoon Mission project, we have introduced the seasonal prediction of the cold wave and winter minimum temperature over the country.
Monsoon Mission is an evident example of thinking globally, acting locally. Rural or urban, businesses or farmers, elders or youths, everyone is awaiting accurate prediction of monsoon. And Monsoon Mission is helping 1.3 billion Indians to realize their dreams.